Hey guys, welcome to the notes for quotient property. The last set of notes that we did was the power property and the product property. So we're going to learn the quotient property today. So just to review, the product property means that if I have two things of the same base, I can add their exponents. So for example, let's do one up here. So this is just an example, and you don't have to write it on your paper. If I have x to the fifth times x to the third, the product property says I'm going to add the exponents. So I have technically 5 here, and then I have 3 here. So this will be x to the 8th, so I can add them. That's the product property. The power property is when I multiply. So if I have x to the 5th to the 3rd, remember the exponent on the outside is more powerful, right? Like we have an extra one, it's even higher. So when we think of addition and multiplication, which one's more powerful? Multiplication is. So we're going to multiply here. So we would have x to the 15th. So that's the power property. So today we're going to look at Today we're going to look at the quotient property. So we're still in Unit 1A. Essential question is, how are patterns in mathematics useful? Like I said last time, patterns are helpful because it allows us to take shortcuts. It allows us to see a pattern and recognize it and be like, oh, I can do this for every problem that I see that is like this. So I don't have a lot on the notes right now. It's because I kind of did it on the way. I kind of built to it. So I wanted to be able to create a pace. So these are the exact same notes that we're going to be going over in class. So in the numerator, I have 3 to the 5th, and then the denominator, I have 3 to the 2nd. So let's go ahead and expand this. What does 3 to the 5th mean? Well, 3 to the 5th means I have 3 times itself 5 times. So that's 3 times 3 times 3 times 3 times 3. So I have itself 3 times. In the denominator, I have 3 squared, which means I have 3 times itself twice. So I have 3 times 3. Well, there's some stuff that I could cancel out here. I could cancel out 2 sets of 3s, so I can cancel out 3 divided by 3, because 3 divided by 3 is 1. And I also have another 3 divided by 3. So now I have 3 times 3 times 3. And what do I have in the denominator? Well, I don't have 0. I technically have 1, right? Because 3 divided by 3 is 1, so I have a 1 down there. And so how many 3's are there? How can I write this in a shorter way? Well, I could write this as 3 cubed over 1, or just 3 cubed. Now, we don't have to write the 1, but remember, every number is technically over 1, so you could. All right, let's talk about the shortcut. I have 3 to the 5th, and I have 3 to the 2nd, and I ended up with 3 to the 3rd. So what do you think the shortcut would be here? The shortcut is I could subtract. So product property, I added. Power property, I multiplied. And here I can subtract. So let's talk about that. If we take 5 minus 2, I get 3 to the 3rd. You can also think of it another way. Where do you have more 3's? Do you have more 3's in the numerator or more in the denominator? You have more in the numerator. So you're going to have 3. You're going to have 3's up there, and you're going to have 3 more. You take the difference. So 5 minus 2 would be 3. All right, let's build into a new example. Let's number these. So this is 1. There's number 2. Number 2, we have 8 to the 3rd. Let's do 8 to the 3rd, and then 8 to the 7th, actually. Let's do 8 to the 7th. So let's expand this. We have 8 times 8 times 8 in the numerator. 8 times 8 times 8 times 8. So I have 8 times itself 7 times in the denominator. All right, so like earlier, I can still cancel stuff out because 8 divided by 8 is 1. So this would be 1, 1, and 1. Does that mean there's nothing left in my numerator? No. Just like last time, there's still something there. It's a 1, right? Because 8 divided by 8 is a 1. So all I have left is 1's. And then how many 8's do I have left in the denominator? Well, I have 4, so that would be 8 to the 4th. So again, we're kind of taking the difference here. So where do you have more 8's? You have more 8's in the denominator, right? The denominator. You have more there, and then you just take the difference. So if you take the difference between 7 and 3, that's going to be 4. You have more of them in the denominator, so that would be your answer. So that is number 2 that we're going to go over. All right, now we're going to build on this a little bit. So we're going to go on to more abstract. So we're going to get to variables. I'm going to do x to the 9th divided by x squared. So using the shortcut that I just saw where I subtracted, right? If I have 9 in the numerator and 2 in the denominator, where do I have more x's? Well, I have more x's in the numerator, right? I technically have more x's in the numerator. And where do I have more x's? Oh, I just asked that, sorry. How many more x's do I have? I have 7 more, so I have x to the 7th. And then that would be my answer. You could do x to the 7th over 1 if you'd like, but you're not required to. The only time I require a 1 is if it's in the numerator, right? Because I can't tell if you have a fraction if all you write for me is this. I need to see the 1 up there. All right, moving on. Number 4. X third, y squared, and then an x in the denominator. Okay. So let's talk. Do I have anything that is the same base? Yeah, I have bases of x cubed and then x. So if I were to simplify this, I have more x's in the numerator, so I know I'm going to have more x's up here, so there's not going to be any in the bottom. And then the difference between the two, well, I have 3 in the top and 1 in the bottom, so 3 minus 1 is going to be 2. So it's going to be a 2 there, x squared. And then the y can't be simplified because there's no other bases that match it, so it's just going to be y squared. Ooh, let me do this in pink, actually. All right, so there's nothing left in the denominator. You could write 1 if you'd like, but you don't have to. Moving on to the 5th example. So we're building up a little bit more and more every time. So we have w to the 5th, z to the 5th, and then 3z to the 4th. So let's do this one. All right. So let's talk about our things, right? So your question might be, well, how do I know when I'm supposed to add? When am I supposed to subtract? So you subtract if you see that there's bases and they're on opposite sides. So if you have a base in the numerator and the base in the denominator that are the same, if they're on the same line, then you're going to be either adding or multiplying. So we'll kind of get to that later. I just kind of wanted to touch on that really quick. So here I have w to the 5th. I can't really do anything with that, so I'm going to leave it as is because it can't be simplified with anything else. Although I notice over here that I have a z here and I have a z here. So I have z to the 5th in the numerator, z to the 5th in the denominator. Where do I have more z's? I have more z's in the numerator, so I'm going to write my z there. And then 5 minus 4 is 1, so you can write a little 1 up there if you'd like, but I'm not going to. If we don't write a 1, it's an understood, yes, there's a 1 there, because there is one of them there. And then the 3 can't be simplified, so it just stays in the denominator. And that's it. Okay, now let's build on this one a little bit more. So I'm actually going to do 6 over here next to it. We're going to do w to the 5th. And we'll actually even have a 9 here. Let's do 9. We'll do 12. Let's do 3 actually. 3. Z to the 2nd. And then w to the 7th. Okay. So here, what do we got? Well, looking at my like bases, 9 and 3 are like bases. Those are regular numbers. I can do 9 divided by 3. And what is 9 divided by 3? That's going to be 3 over 1, right? You don't have to write the over 1 if you don't want to. I will erase it eventually, but if that helps you, you may write it. It does not bother me in any way. All right, so let's look for some more like bases. Well, I see I have w to the 5th and I have w to the 7th here. Well, where do I have more w's? I have more w's in the denominator, and I have 2 more on the denominator, so I have 2 there. So 7 minus 5 is 2, so you take the difference, just like earlier. And then the z's, there's nothing that you can do with them. There's nothing that you could simplify, so it stays up in the denominator, or in the numerator, sorry. And then at this point, I'm going to erase my 1, and I'm going to circle my box my final answer there. All right. Let's go on to number 7. Okay. Let's do a negative. So we're going to add some negatives in here. We're going to do negative 5 over 5 v u cubed, and then u to the 4th. Actually, v u to the 4th. Okay, let's do this one. Okay. So let's start simplifying, right? The negative sign is just there, so you just leave it as is. You don't really need to mess with it. Not a big deal. So 5 divided by 5, what is that? 5 divided by 5 is 1, so this cancels. V divided by v, that also cancels, right? Because if 5 divided by 5 is 1, then v divided by v is also 1. It's just like how apple divided by apple is also 1. Okay, so those are all 1. So just go ahead and write a 1 up there, since that's the only number I have up there right now. And then I have u cubed divided by u to the 4th. Now, where are my more u's? Do I have more in the numerator or the denominator? more in the denominator, and then I have 1 more in the denominator, so I'm going to write a 1 there, because 4 minus 3 is 1. And that's actually my entire answer, because I've already simplified everything that I could, and that's all I have. All right, number 8. Now, again, I'm building on difficulty here, so we started off pretty easy with numbers, and we're just building and building. So it's just going to be like the last set of notes. All right, so here I have 12 divided by 8. Well, 12 divided by 8 doesn't go in evenly, right? So I do want to show you how to change a number into a fraction. So give me 1 second. I'm going to grab a calculator. Actually, I'm going to use my own calculator. So we're going to use my pink one here. All right, so we need to do 12 divided by 8, but we don't know that, and maybe it doesn't even go in evenly. So I'm going to type in 12 divided by 8, and I hit enter, and I get 1.5. Well, I know that this is in a form of a fraction, so I need to change this to a fraction. The way you change it to a fraction is that you hit the math button, and then you see how it says frac there, you're going to hit enter, and then you're going to hit enter again. So you're taking your answer, and you're changing it to a fraction, and then you hit enter, and it gives you 3 divided by 2. So that is your new fraction there. So you have 3 divided by 2. So you have a 3 in the numerator, 2 in the denominator. So that took care of the 12 eighths. Now we're going to move on to our variables. I have the same bases of x to the 4th, and I have the same base of x to the 3rd, so those are both x's. I have more x's in the numerator, so I'm going to write an x up there. And then I know that I have 1 more, so there's technically a 1 there. Again, you don't have to write it. And then for my y's, I have more y's in the denominator. Okay, and how many more y's do I have? I have 6 more, so I take the difference between those. So really, we're just subtracting. That's what the quotient law says. You're going to subtract. And I'm going to go ahead and highlight those. All right. So that is it for that problem. You know your problem is completely simplified when you only have 1 of every base. So you can't have more than 1 x, you can't have more than 1 y, you know, you want 1 of everything. You don't want duplicates or triples of anything. All right, moving on, we're number 9. All right, so we're getting a little bit more complicated. We have 1, 2, 3, 4 more problems left, so just bear with me. So we have negative 8x to the 6, y squared times 2y cubed, and don't get too overwhelmed, it's not too bad, divided by 8x. All right, so we're going to treat this as 2 separate parts. So since fractions have a top and a bottom, we're just going to deal with just the top for now. So just pretend like this part isn't there, okay? So what can I multiply? Well, the entire top section is all multiplication, right? So everything's being multiplied together. And I want to try to simplify everything as much as I can. Now, since they're all on the same line, you're going to be either adding or multiplying your exponents. And you're only multiplying if you have like parentheses and like an extra exponent, because it's like more powerful, right? More powerful is multiplication. So here I have negative 8, and I also have a 2, and I can multiply those two, and that gives me negative 16. I also see that I have some y's that are the same. So same base here, I have y cubed and y to the 2nd. So that's going to be y to the 5th, right? We're going to add those. I have 2 y's multiplied by 3 y's. That's going to be 5 y's multiplied together. And then lastly, I have a x to the 6th that I can't really do anything with, so I'm just going to write that there. Okay, and if you wanted to, you could also write it this way. You don't have to write it with the y in the front. You know, it's all the same. It's all multiplication. Just like 2 times 3 is the same thing as 3 times 2. Okay. Actually, I need to change that to blue. Make for the same. And then I'm going to go ahead and bring back the part that I scratched out. So I'm going to write the 8x down there. So you simplify the numerator, and now we're going to simplify the entire expression. Okay. So I see that I have negative 16 divided by 8. That's going to give me a negative 2 in the numerator. Okay, and then I also have x to the, let's see, we're going to highlight this. What color? Let's do purple. I have x to the 6th, and I have x to the 1st here, right? There's technically a 1, so that's going to be 6 minus 1, so x to the 5th, right? There's more x's in the numerator. And then the y's I can't really do anything with, so I just have y to the 5th all by itself. And then that would be my final answer because I have one of every variable. All right, so that was number 9. Moving on to number 10. Oh, actually, I lied. I think we have 4 more now. So we're going to go one step extra here. All right. Oops. All right, so here we have a lot of stuff, right? So just like earlier, you want to look at each part separately. So let's look at just the numerator. Well, the numerator I see is pretty simplified. I can't simplify the 3, can't simplify the A or the B. So I can't really do anything up there. So that part's already simplified. So now I'm going to look at the top. So I'm going to actually copy that all down as is because there's nothing else to do to it. Okay. And then I'm going to go ahead and look at the denominator down here. So I know I have 2, and I know I can multiply that by a 6, and I can multiply that by a negative 2. So 2 times 6 times negative 2 gives me negative 24. And then I know I could take the A's and I can combine those. So I have 8 of the first, so I have 1 A, and I have 8 of the fifth, so that's 5 A's. So that's going to be 6 A's in total, so 8 of the sixth. So 6 A's are being multiplied together. And then there's nothing else I can do with that b to the cube, so I'm just going to write that up there as is. So now I've simplified this, and I'm going to simplify it one more time. I see that I have 3 over negative 24, so I'll go ahead and show you in the calculator how to do that. I have 3 over negative 24. Okay, so I'm going to take my 3 divided by negative 24, and don't forget that your negative button is this one right here, not that one. This one's the minus. So 3 divided by negative 24, hit enter. I'm given a decimal, but I know how to change it to a fraction. Hit math, enter, enter. And I get negative 1 over 8. So I'm going to go ahead and go down here and write negative 1 over 8. It doesn't really matter where your negative sign is as long as it's there. So I'm just going to go ahead and put mine on the outside of the fraction. But if you wanted to, you could put it next to the 1 or next to the 8. Doesn't really matter. So I have the negative there. It's really bothering me that it's 2 different things. Okay, so I have negative 1 over 8. I took care of those 2 things, right? So I took care of this. And now I'm going to take care of the a cubed and the 8 to the 6. So a cubed, 8 to the 6. Where are there more a's? There's more a's in the denominator. And there's 3 more in the denominator. So there's 6 minus 3 is 3. And then next, I'm going to do the b's. I'm going to simplify those. So I have b to the 4th and b cubed. There's more b's in the numerator. And that would be only just 1b more because there's 4 up there and 3 down there. All right, so this is kind of a little bit messy. So if you wanted to really simplify this, this would just be negative b over 8a cubed. So you don't have to write all those extra ones if you don't really want to. All right, moving on. Okay, this one we're going to start involving the power. So in this one and then the previous one, we introduced the product rule as well as the quotient rule together. So we use product rule up here, and then we use the quotient rule for the entire thing. Same thing here, we use the product rule when we were coming from there to there. And now we're going to use the power rule. So I have negative x squared to the 4th, and then I'm going to have 3x squared to the 3rd. All right, so let's talk about this. Let's simplify each part by itself, right? So let's simplify the denominator or the numerator first. So I know that there's a negative sign in front of my x squared, and I know that I'm supposed to distribute this and multiply, right? There's a exponent on the outside, so it's more powerful. So this negative 1. We have a negative here, but there's no number, right? So normally we see like negative 2x or something like that, but there's no number. So if it's just like negative x, one number is technically there. Technically a 1. So there's technically a 1 there. And I'm going to go distribute now. So I have negative 1 to the 4th power. Now I'm going to put that in the calculator and show you how to do that now. So when you see negative numbers and you want to put it to the exponent, you have to put parentheses. So I have a negative here. I'm going to do negative 1, and I'm going to close those parentheses. and you hit this little up arrow here that indicates that you want an exponent. On the pretty calculators in my classroom, it like automatically gives you a box, but I have a really old calculator, so it doesn't do that. So I do -1 to the 4th power and hit enter, and it gives me +1. So it's really urgent that you do use those parentheses because people do not use them and then mistakes happen. So -1 to the power of 4 is a +1. And then we're going to do x squared to the power of 4. And remember, this is the power property, so you're going to multiply your exponents. So it's going to be 2 times 4, which is 8. All right. Now let's look at the denominator here. In the denominator, I have 3x squared to the power of 3. And I'm going to do the same thing. I'm going to take that 3 and I'm going to distribute it on the exponent. It doesn't mean 3 times 3. It means 3 to the power of 3, which means 3 times itself 3 times. And 3 times itself 3 times, or 3 cubed, is 27. And then the next one, I would have x squared to the power of 3, and that's going to be 2 times 3, which is 6. Okay, I'm almost done here. I have some things to simplify. So 1 divided by 27 is going to stay as is. There's not much I can do there. With the x's, I know that I have the same base, right? There's 2 of them. So I know that I have more in the numerator, and there's 2 more there. So 8 minus 6 is 2. And then this would be my simplified answer. You might also write x squared divided by 27, so without the 1 there. Oops. That also works. All right. We have 2 more examples left. Okay. So these notes are pretty long, and that's because I want to show you all the types of problems that you might see before you see them on a quiz or a test, right? I don't want you to be the first time you see something to be on your quiz or test. You want to be at least exposed to it, seen it before kind of thing. All right, so this is a giant set of parentheses. So the first thing that I want to do is I want to simplify all of this before I even touch this outside portion, right? So I'm just going to pretend like those parentheses aren't there, and I'm going to simplify a little bit. I'm going to leave the m squared alone, and the reason why I do that is because there's nothing else up there I can simplify it with. It's all by itself, nothing much. Down here, I see that I have like bases where I have b cubed and a b. Well, I know b cubed times b, I have another b, so I have 4 b's down there, so I have b to the 4th. The 3 kind of stays alone, 3 is the same, and then the m squared is also the same. You always want to write your coefficients in the front. The coefficient is the number being multiplied, like just the plain number, so 3 would go in the front. I don't really want it in the middle. If you put it in the middle, you're going to need a little multiplication sign like this. So it's just easier if you put everything at the front of your expression. All right, and then I'm going to go ahead and draw back in my parentheses. Okay, now at this moment, I'm going to go ahead and distribute. So same thing, you're going to do the little multiplication things. You're going to do it here. So you're going to have m to the power of 4, because 2 times 2 is 4. Once you distribute this exponent to every single term, every single item, then your parentheses actually goes away. So, and then we have to do it to this one as well. So we have 3 to the power of 2. Well, 3 to the power of 2 is 3 squared, which is 3 times 3, and that is 9. Then we have b to the power of 4 times, or up to the power of 2. So we have b to the power of 8. So you multiply those. 4 times 2 is 8. Again, we're using the power property here. And then the last one is going to be m squared to the power of the 2, or power of 2. So it's going to be 2 times 2, which is 4. Okay, we're almost done. We see that we have some like terms here. So I have this one and this one. These are like. So I'm going to simplify those. So m to the 4th divided by m to the 4th is what? 1. So that actually just cancels, and we just have a 1 up there. And then we have 9b to the 8th, because those can't be simplified any further. All right, last one. Number 13. So this one's a big one, all right? So actually, I'll just do these separately. A cubed, b cubed, squared, negative 3b, a to the 4th, cubed, oh, not cubed, squared, and then all to the power of 2. So this one's huge. So there's lots of parentheses with this one. So remember, you're going to isolate as much as you can. So I'm going to work with this part here first. So I'm going to go ahead and copy what I see in the denominator because I'm not going to mess with it yet. Or should we? Maybe we will. We'll mess with it later. But for now, we're not going to mess with it. All right. So I see that there's an exponent on the outside of the parentheses, so I know I can multiply in. So a is going to be to the power of 6. And then we're going to have b to the power of 6 as well, because 3 times 2 is also 6. So I've taken care of that. And now I'm going to look at the denominator. Do the same thing. So I have 2 here. I'm going to distribute that in. So remember, if you have a negative number, you must use parentheses. And if you want to be safe, you can always use parentheses. You have to do -3 to the power of 2. And if you're wondering where I got that 2 from, it's right there, this little exponent that I have to distribute. So I'm going to hit enter. That's going to be a positive 9 because -3 times -3 is positive 9. So I have a 9 here. And then I also have to do it to this one. So there's technically 1b there. So I do 1 times 2, which is 2. And then I have a to the power of 8. So it's going to be 4 times 2, which is 8. And then last but not least, I have that giant set of parentheses on the very outside with the 2. I'm going to do this all over again. I'm going to distribute again. So I'm going to have a to the power of 12 because 6 times 2 is 12. Okay, and then I have b to the power of 12 because 6 times 2 is also 12. And then I'm going to have this 2 in here. So I have 9 squared. So 9 squared is not 9 times 9. It is 9, or it is 9 times 9. It's not 9 times 2. So make sure you don't do 9 times 2 on accident. So it's going to be 81. And then I'm going to have b to the power of 4 because 2 times 2 is 4. And then I'm going to have a to the power of 16 because 8 times 2 is 16. All right. Now we can decide to simplify things now. So let's have a little fraction here. Go ahead and get my colors ready. So I'm going to go ahead and look. Well, I notice that my a's, so I notice that I have 2 bases of a's. I have a to the 12th and a to the 16th. Well, there's more a's in the bottom, so I have a, and I have 4 more in the bottom, because 16 minus 12 is 4. Now, the 81 I can't really do anything with, so I'm going to leave it as is. And then I see that I have a b to the 12th and a b to the 4th, and those can simplify. And that's going to give me more b's in the top in the numerator, and I'm going to have 8 more up there. And so now I've simplified the whole expression. I can't go any further, and that is my simplified answer. This is a lot. It's a lot to take in because we started so little, and then we got more and more and more. So if you have any questions, please feel free to come and ask me during tutorials.